where we're connecting to multiple physical switches northbound. So let's say that fabric interconnect A is going to whatever, 3751, and it's going to 3750 number 2. And then behind 3751, this is where we have our DMZ. 3752, maybe this is where we have our like the public web servers. And the issue is going to be that if the FI pins the VNIC for the DMZ that direction, and if it pins the VNIC for the public network in the left, the end result is they're not going to be able to reach each other. But a simple solution for this would be to put a trunk link between the switches and then trunk all VLANs. So even if the public traffic were to go to the left, we would still have an Ethernet or a layer 2 path to go to the right. This just means that you don't have disjoint layer 2. Okay, that's by far the simplest design. But for whatever reason, you may not be able to do that based on your individual environment. So there's 3 real fixes to deal with this in the UCS. Okay, first of which is we're going to edit the trunking allowed list. So on the UCS manager, we're going to tell it that this uplink is only running VLAN 10, this uplink is only running VLAN 20. Then when you make your pinning decision, you're going to have to pin VLAN 10 that way, pin VLAN 20 that way, and then it's automatically going to fix itself. The issue is that it doesn't automatically do this when you're running in end-host mode because it's not running spanning tree to figure out which VLANs exist on which ports. Okay, if we went to option number 4, which is just to turn Ethernet switching mode on, you would never run into this problem. Because simply based on the BPDUs, it's going to be able to detect, is that switch running VLAN 10 or is it running VLAN 20? Because the VLAN number is encoded inside the spanning tree update. Okay, so it would just learn the MAC addresses wherever they're supposed to be. The other option is that we could give multiple VNICs to the OS because the pinning is happening per VNIC. But the key is that it's not happening per VLAN. So this one we'll look at later. Option number 3 is a little bit more advanced solution. The simplest config answer is going to be number 2, is that we're just going to edit the trunking allowed list. There's 2 different ways that we could do this, either under the VLAN manager or under the VLAN groups. Okay, either of them from the GUI point of view are going to be under the LAN tab and then under the LAN uplinks manager. So if we go to LAN and then all and start back at the default page, okay, so LAN, this is in the bottom of the middle of the page. It says launch the LAN uplinks manager. Okay, so we're going to open this up. This should open in a new window, and then we're going to go under VLANs. Okay, this shows what VLANs we have created. So in this case, we have 3 VLANs. We have default VLAN number 1, and then we have VLAN IDs 10 and 20, which are mapping to these names. Okay, we have on VMware Management, VLAN 20. If we then look under the VLAN Manager, this is going to say what particular VLANs are mapped to which uplinks. So I could go under VLANs, and I'm going to say VLAN number 20. I only want this to go to uplink interface number 3 on Fabric A. So you select what link you wanted on the left, you select what link you wanted on the right, and then on the bottom you click Add. And the end result is that it's editing the trunking allowed list. You can also accomplish the same thing by going to VLAN groups, and then we would configure 1 group per uplink, okay, or 1 group per disjoint layer 2 network. So for example, I would say that this is going to be a VLAN group that's named DMZ. Okay, DMZ includes the VLAN 20 VLAN. Okay, and VLAN 20, I want to forward this on Fabric A port number 3. Okay, I also want to forward it on Fabric B port number 3. Okay, so you'd have to do it separately, A versus B. Okay, so finish. Then I'm going to create another group that would be like management. Okay, we'll say that's going to be for the management VLAN. And then the management VLAN, I want to trunk this on port number 4 upstream. Now, if we look at this from the CLI point of view, behind the scenes, it's not making any complicated changes. The only thing it's doing is just saying switch port trunk allowed VLANs. So if we show interface trunk, we should now see port number 3 is trunking VLAN 20. Port number 4 is trunking VLAN 10. Previously, they were both trunking 10 and 20, which is the default behavior. Okay, but now we're just editing the allowed list. 10 is going that way, 20 is going that direction. Now, assuming that these match up with what the 5K is doing, so if we go to 5K1 and look at the show interface trunk, port number 9 is trunking VLAN 10, port number 10 is trunking VLAN 20, so actually I need to reverse these. Let's say on E19, switch port trunk allowed VLAN is number 20. And then on port 10, allowed VLAN is number 10. So show interface trunk. Okay, they're trunking 20 and 10. On the UCS side, likewise, they're doing the same thing, 20 and 10. So if we go to send traffic, let's go to the end host. And then we're trying to ping to 10.0.0.102. Which we can reach, and 20.0.0.101. Okay, so let's clear the ARP cache, ARP-D star. And let me make sure both of these interfaces are up. So let's go to 5K1 and show interface E19 to 10 status. Okay, port 9 is disabled, so let's go to E19, no shut. Then from the server's point of view, we should see that we get connectivity both ways, which we do. Okay, so we can reach the 10 network, we can reach the 20 network. So these two packets are coming up to 5K1. 5K1 is then looking in two separate tables. It's saying show MAC address table for VLAN 10, show MAC address table for VLAN 20. And then notice here, even though it's the same address, it's in two different tables, and we're switching them in two different directions. So one of them is going directly down to the UCS. One of them is going, looks like it's going across to the other switch and then down. And actually, I think it may be the 001 address. Let's ping from here. Let's ping 10.0.0.102 and ping 20.0.0.101. Then let's look at the ARP cache. Show IP ARP. Okay, so we want to show MAC address table, pipe to include this guy or that guy. Okay, those are for VLANs 10 and 20 respectively. So the VLAN 20 address we're learning on E19. The VLAN 10 address we're learning on E110. Simply because the trunking allowed list is matching on the UCS on a one-to-one basis of what it's matching on the 5K. Now, the other reason that this can become a problem, though, is that the pinning is automatic from the UCS northbound. We're not forcing it to use one way or another. Essentially, what it's looking at is to figure out what interfaces are trunking what particular VLANs. Then out of that list, I'm going to choose typically the lowest number port when we're pinning first. Then each subsequent pinning decision is going to go to the next higher interface. So it's basically just doing it in a round-robin basis, like 3-4, 3-4, 3-4, over and over and over, assuming that both VLANs are allowed in both directions. In this case, 10 is going one way, 20 is going the other way. So it means that the VNIC that's using VLAN 10 has to pin to the VLAN 10 link. The VNIC using VLAN 20 is pinning to the VLAN 20 link. The end result is that they're both going in the correct direction. Okay, but again, where this can be a problem is when they're not matching on the other end. Okay, so let's say that we were to fix this on the 5Ks. Okay, 5K, we're going to trunk both VLANs in both directions. So switch port trunk allowed VLAN is all. Okay, let's clear the ARP cache and clear the MAC address table. Clear MAC address table dynamic. Okay, then let's look for those two addresses. Right now, they should not exist. We go to ping the destination. The switch is generating ARP. The ARP is going to flood out, and then when the return comes back in, the return traffic is where we're learning where that destination MAC address is now located. So since the UCS is forcing the traffic to return on port number 10, based on the dynamic pinning decision, it means that now 5K1 subsequent outbound flows are also going to follow that path. So it's just normal, regular layer 2 Ethernet switching logic. The way that I'm switching towards you is the same way that you're switching back to me, because the MAC addresses are learned in the same direction. So when I forward my packets towards you, you're learning my source MAC address in that direction. Then when you forward the packets back to me, I'm learning your source MAC address in this way. It's going to be the same port in both ways. Okay, then likewise should be the same when I ping to 20.0.0.101. We ARP for the destination. We're going to see the reply come in E19, and then we know where the destination is located. Okay, now from the CLI of the UCS, there's a second command in order to check what this decision is, which is the show platform software ENM internal info VLAN database or VLAN DB ID and then the VLAN number. Okay, the shortcut for this is from the CLI, you say which pipe include VLAN DB. It's the only command in the parser that has the keyword VLAN DB in it. So on the UCS CLI, we say which pipe include VLAN DB. Okay, there's our command. It's show platform software ENM internal info VLAN DB. The identifier is number 10. Okay, so VLAN I10, VLAN number 10. It says the membership includes E14. That's what links we're trunking it on. And then the designated receiver is E14. Okay, for number 20, this should be pointing towards port number 3, because that's what we're editing in the allowed list. Okay, but now let's say that we have a bunch of other interfaces going to other switches. Okay, there's other 5Ks that are physically wired to the UCS, but we don't have them plugged in. So what I'm going to do is to go back to the UCSM, and I'm going to delete the VLAN groups. Okay, so under VLAN groups, under LAN cloud, we're going to delete these two groups, which is going to remove the trunking allowed list config. Okay, so we're going to go back to the default config where it's doing the dynamic pinning. Okay, additionally, what I'm going to do is to go under equipment, under Ethernet ports 5 through the end, let's say like 5 through 20, and we're going to configure these as regular uplinks. Okay, now you should be able to control click on these. I think this is an issue with the HTML5 interface. Let me try this under LAN uplinks. Let's go to the LAN uplinks manager. Then let's go to unconfigured Ethernet ports. And let's say these interfaces, let's see, can we control click? We can do it in here. No, this is something wrong with the browser. Okay, but I'm going to configure these as uplinks. So let's say just ports 5, 6, and 7 are uplinks. Okay, so right now we have 3, 4, 5, 6, 7. They're all configured as trunks. If we go back to the CLI from the UCS and look at the show interface trunk, we should see that all 5 of these interfaces are now trunking the same VLANs. Okay, they're trunking 10 and 20. If we look at the show LLDP neighbors, these are going to other switches. Okay, they're going to 5K2, they're going to 5K3. The point being, though, is that they're going to other portions of the network that do not have layer 2 connectivity to 5K1. So 5K1 has multiple ports, is trunking all VLANs on them. The UCS is trunking all VLANs back to 5K1. But it also has alternate ports going somewhere else physically in the network that does not have a layer 2 connection over to 5K1. So now the potential issue is going to be if the pinning decision, from the UCS manager point of view, if the pinning decision is pointing us towards E1, 5, 6, or 7 for either of these VNICs, the end result should be a traffic black hole. So if we look at the show pinning for the border interfaces, it says virtual Ethernet 698, it pinned to E16. This now means that if I was to go to port number 5 or 5K1 and ping to 20.0.0.101, we see now that the traffic is lost. Okay, so let's say that we're going to try to manually fix this from the UCS manager. What we're going to do is we're going to take this NIC, the virtual NIC, going down to the service profile, and I'm going to configure effectively what is like a static route, which is called a pin group. Okay, a pin group is when you want to manually decide which uplink are you using to leave the chassis. Or excuse me, not leave the chassis, but to leave the fabric interconnect. So from the FI northbound to 5K1. We're going to say that on this virtual Ethernet, so on virtual Ethernet 698, show interface veth 698, this is going to chassis 1 slot 5. So we're going to take this virtual NIC ETH0 and we're going to statically assign it to uplink E14. Okay, so we're going to do a static pinning towards it. Okay, the way we do this is first we go under the LAN tab. We go under LAN pin groups. So we're going to create a pin group. And let's say that this is Fab A port 4 is on fabric A, interface E14. And this, unfortunately, is another bug in the UI. Okay, I may need to load the Java interface. There we go. Okay, E14. Okay, we successfully created the pin group. We're now going to take the pin group and apply it to the service profile. So we're going to go under servers. We're going to go under Brian profile 1. We're going to go to vNIC ETH0. Okay, this is where the management traffic is on. And we're going to assign a pin group. A pin group is Fab A port 4. I'm not 100% sure if this is an issue with Chrome or an issue with the UCSM itself, but for some reason, some of these drop-downs you just can't click through. Let me try going back and forward again. Okay, I'm going to have to do this from the Java interface. So let's go back to the main browsing page. 192.168.0.100. And then let's launch the Java version. So let me log back in. Okay, so the Java interface is up. This should be able to fix it. So let's log in as admin. Okay, then we have the same tabs, but it just looks visually a little bit different. So we're going to go under servers. We're going to go to the profile. So service profile, Brian profile 1. Then under vNICs, vNIC ETH0. Then our pin group is Fab A port 4. Okay, save changes. Okay, what this now means is that if we go to the CLI and we look at the show pinning, vETH 698 is now pinned to E14. Okay, previously 698 was pinned to E16. If we look at the show pinning for the server interfaces, this is going to tell us that this NIC is hard pinned. Okay, sticky, yes, hard pinned. So this means it's basically like a static route, that any traffic coming from this port is statically forwarded towards E14. Now, the issue that we're going to run into again, though, here is that the forward traffic, so the southbound to northbound traffic, is not necessarily the same as the northbound to southbound broadcasts. Okay, and what I mean by this is that if we look at from the northbound 5K's point of view. Okay, let's look at the show spanning tree for VLAN 10. Okay, we see that we're forwarding VLAN 10 out both directions. This means that when I send an ARP, okay, when I generate a broadcast, it's going to go out both of the interfaces. The UCS is trying to prevent the case that those multiple broadcasts get delivered down to the OS because we don't want multiple copies of the same packet. It's coming in two different interfaces, so it's technically two different packets, but it has the same identical payload. So the upper layer application doesn't need more than one copy. To deal with this, what it simply does is to throw away any of the copies that come in the non-designated receiver port. And the designated receiver port is going to be a dynamic election based on what interfaces are currently available. Okay, so if we go to 5K1 and let's try to ping both of the destinations again. So we ping 10.00.102, which is fine. We ping 20.00.101. Okay, everything looks fine. Okay, we now run into a case where there's a failure. So interfaces E19 to 10, they get shut down, but then they come back up. Okay, so there's a link flap. Okay, if we look at the ARP cache, we see that 20.00.101 is cached and 10.00.102 is cached. So let's go ahead and ping again to 10.00.102. Can't reach it. We should be able to reach 20.00.101 though, because this was hard pinned. Okay, this was statically routed essentially to the interface, so there's no problems there. Okay, now we cleared the ARP cache. So let's go to the VLAN and let's shut this down. That's going to clear the cache. Bring it back up. Show IP ARP. Okay, we don't have any entries for the 20 network. We now go to ping 20.00.101. And now we can't reach it. Now notice here that I didn't fail the physical interfaces. So from the FI's point of view, there was not a link flap. It didn't cause it to repin to an alternate interface. The only thing I did from 5K1 here was essentially just clear the ARP cache. So I was able to reach 20.00.101. Something changes in the network. There's some sort of convergence event. And then all of a sudden, I'm no longer able to reach the destination. Okay, the reason why is that when 5K1 is sending the ARPs, it's sending the broadcast frames down to the FI, the FI has chosen a different interface besides port number 4 as the dedicated receiver for VLAN number 20. Okay, and the reason I know that is because the packet is being lost. Okay, but otherwise, the way that we can tell this is to say which pipe include VLAN DB, and then let's say the command that output it here. So show platform software ENM internal info VLAN DB ID is 20. It says there's 5 possible interfaces that we could be receiving this flow on, this particular VLAN. It's trunked on VLAN or interfaces E13, 4, 5, 6, and 7. I've chosen the dedicated receiver as port number 7. This means that if a broadcast comes in E13 and it's in VLAN 20, end result is we drop it. Now the problem here is that when we look at the show CDP neighbors or the show LDP neighbors, port number 7 is not going to the same physical switch as where we're actually sending the traffic from. So there's no east-west connection between 5K1 and 5K3, or in other words, this is a disjoint layer 2 network. So making the pin group did solve the reverse path forwarding issue that is for traffic going from southbound to northbound, but it did not solve the issue of the north to south broadcast traffic. They're technically two different decisions. Now, the way that we can tell that this is 100% the problem is that if we were to go to 5K1, let's ping the destination, we see we're not able to reach it. Now let's say that we were to statically map the MAC address to the IP address. So we're going to go to the VLAN interface. We're going to set an ARP entry, okay, IP ARP. The destination address is 20.0.0.101. The MAC address, if we scroll back up, the MAC address was this guy here. And now we ping to 20.0.0.101. We can reach it. What this is showing here is that the unicast flows go through a different loop prevention mechanism than the broadcast and the multicast flows do. So the unicast is going to be based on the forward pinning decision when you look at the show pinning border interfaces, show pinning server interfaces, or show pinning interface vEth. The northbound to southbound broadcasts are going to be subject to the dedicated receiver port or the G-pinned port check. So out of this, there's no way to manually assign which interface that we're actually listening on. So instead what we would have to do is either solve disjoint layer 2 northbound, okay, like we could configure a trunk between 5K3 and 5K1 that is carrying VLAN 20, which means that the ARPs would be received in all of the ports, or we could limit the allowed list so that VLAN 20 is only allowed on port number 4. The point of this being is that setting the pin group for LAN pinning does not solve the disjoint layer 2 issue. Because it may solve it from a forward point of view as we're going from southbound to northbound, but it doesn't resolve it in the reverse manner for the dedicated receiver port. Okay, now let's say we were to undo our very last step, which is on 5K1, we went to VLAN 20, and we did a static ARP. Okay, so I'm going to remove the ARP. Let's look at the show IP ARP. Destination is no longer cached. End result is that we should be dropping the traffic. Okay, now what I'm going to do is to go to the other interfaces that are connected to the UCS. So I'm going to go to 5K1 port 9 and shut this down. 5K2 port 11, shut that down. And then 5K3 ports 9 and 10. Shut those down. Okay, interface E1, 9 to 10, shut. Now on the FI, if we look at the show platform software, E&M internal info VLAN DB ID 20, it says now the only dedicated receiver port or the only membership is only E14 because the other interfaces are now down. Okay, they're in the down state. They're ebb and down on the other side. This should now mean that 5K1 will be able to reach the destination, but only coincidentally, because now the broadcast receiver just happens to be mapped to the interface that we're actually sending the ARPs on. But the issue now is that if there's a convergence event later and an interface flaps on the FI, it's going to re-elect which interface is the broadcast receiver, and if it points to a new interface, the end result is that the traffic is going to be dropped. Okay, so if we go to those interfaces that are disabled, let's no shut them. So 5K1, that was port number 9, no shut. 5K2, port 11 is no shut. 5K3, ports 9 and 10 is no shut. From the FI, we should now see 5 interfaces as potentially being elected the receiver. Only E14 actually is elected the receiver currently. If we show CDP neighbors on interface E14, that's going to 5K1 port 10. 5K1, we now go to the VLAN, shut it down, bring it back up, look at the show IP ARP. We should see the cache is empty for VLAN 20. We ping to 20.0.0.101. ARPs are now going in the correct direction. Okay, but now there's another failure. We go to port number 10. This flaps. Okay, so interface E110, shut, no shut. From the UCS point of view, we should now have elected a new interface as the designated receiver. Designated receiver is now E16. So even though the physical links are still in the same state that they were before, so if we show spanning tree for VLAN 20, we should see this forwarding on port E110. We go to ARP for the destination. The issue is now actually the VLAN is shut down. Interface, VLAN 20, no shut, ping 20.0.0.101. We go to ARP to the destination. The UCS is receiving the broadcast in the wrong port. It throws them away. The end result is that the ARP is not getting down to the end host. And again, we could show that this is 100% the problem, because if we were to statically map the IP address to the MAC address, we would see that the frames are getting through. So the key point being is that doing static pinning on its own is not enough. Either we would need to solve the disjoint problem upstream, so do a trunk link between 5K1, 5K3, whatever the other switches are physically, okay, so it's no longer disjoint. We could change to Ethernet switching mode, okay, because in switching mode, you're not running pinning. You're running regular spanning tree, and that's going to fix it automatically. Okay, the other way is that we're going to edit the trunking allowed list. Okay, the multiple VNICs to the OS, we'll talk about that later. But option number 2 would mean that if we removed VLAN 20 from the other interfaces, it means that there's only one possible way for the broadcast receiver to be elected, which means that we're going to have to forward the traffic in that direction. Okay, so again, from FIA, when we look at the show platform software command, it says there's 5 possible ways VLAN 20 can forward. What we now do is we go to LAN Uplinks Manager, and unfortunately the Java interface for this is really slow, but for LAN Uplinks Manager, then VLANs, VLAN groups, we're going to add a VLAN group. Okay, this is VLAN 20, let's say, so it's VLAN 20, is applied on Fabric A port number 4, which now from the CLI, if we look at the dedicated receiver, it says there's only one possible way to go. End result should be now when 5K1 ARPs, these should be allowed to come in, and we now get connectivity. So it basically means that whatever VLANs that you're trunking from the northbound switches south, you need to make sure to match those on a one-to-one basis with the UCS. And the easiest way to do this is with the VLAN groups. You say this group is going towards my DMZ, this group is going towards public, this group is going towards development. Then as you need to add VLANs later, you simply add the VLANs to the VLAN group, and then they're automatically going to be mapped to that interface. Okay, what it's really doing behind the scenes is just editing the trunking allowed list. If we show interface trunk, what I did by adding port 4 to the VLAN group is it removed VLAN 20 from the other links. So since VLAN 20 is only allowed on port number 4, it means that this is the only possible way that the broadcast traffic can come in. And it also means from the virtual Ethernet, this is the only way that the traffic can pin northbound. So traffic is both leaving that direction and being accepted in that direction. Okay, there's a question here. Do I have a graphic to help understand this better? There is a document on Cisco's website that talks about the specific issue. If you just search for UCS disjoint layer 2, it's this first regular result here, deploying layer 2 disjoint networks in upstream end-host mode. Okay, in the case they're describing here is that you have 3 different types of networks upstream. You have the production network, the public network, and the backup network. The issue is that if VLAN 10 broadcast receiver was elected on this port physically does not go to the segment with VLAN 10. VLAN 10's over here. So it means that the broadcast receiver would have to be elected on this interface, this one, or this one. But in order to eliminate these other 1, 2, 3, 4, 5, 6, 7, 8 links, it means that we would have to remove VLANs 10 and 20 from the allowed list and only allow them on those 4 interfaces going towards production. So the final config from the UCS point of view would be saying that 10 and 20 are going this way, 31 and 32 are going this way, 40 and 41 are going that way, which means that the dedicated receiver port is always going to be pointing in the reverse direction. So only links that have the VLAN allowed are candidate to be elected the receiver. And if the only links that have the VLAN allowed are the ones that actually physically go into that portion of the network that has the VLAN, then you don't run into the problem. Okay, we'll see this again when we talk about in-band versus out-of-band management. And we are going to have to configure disjoint layer 2 in order to configure in-band management. So if you still have questions on it, don't worry. It is a pretty confusing point about the system. But we'll come back to this later in a couple other examples and then see a practical case with it. But the big thing to remember about this is the shortcut, the which command. Which pipe include VLAN DB. Then from the CLI, we can say, just copy and paste the full command. Show platform software, ENM internal info, VLAN DB, and then whatever the VLAN ID is.